Hi, AP Pre-Calc. This is Miss Adams from Flamingo Math. We're going to finish up lesson 313. This is our second day. And as a disclaimer, I just want to say that the AP Pre-Calc course and exam description does not test or include topics that involve complex numbers in polar form, de Moivre's theorem, or roots of complex numbers. However, I have been asked by some calculus teachers that I teach this section for their upcoming students. So in this case, you could skip this lesson. We're going to use the complex plane with two axes in order to graph complex numbers where the real axis and the imaginary axis, the real axis is the horizontal axis and the imaginary axis is the vertical axis. In this first example, if I want to graph, the real part is 3 and the imaginary part is 4i, we would move right 3 and up 4, and that one point would be my location for that complex number at A. 0 to I is going to sit on the imaginary axis. -2, 3i would be right here in quadrant 2. -4 and 0i is sitting on our real number axis. -1, -2i is down here in quadrant 3. And then 3, -1i is down here in quadrant 4. Example 9, we have absolute value of complex numbers. So again, this is ideas that could be used in a BC calculus course. So we want to graph the terminal side of our ray here. We're going to drop the perpendicular back to the x-axis, form a right triangle. This is the absolute value, which is the hypotenuse. That's our B value. This is our A value. This is our theta. These are our pieces of information that we need, similar to things we've already seen. And notice if A is negative and theta is the opposite of B over A, you would need to add pi in order to get the quadrant that you're in. So, for example, if I'm over here and this is my ordered pair AB right here, the calculator is going to be restricted on -2 pi. I'm sorry, on -pi over 2 to positive pi over 2. Calculator is restricted for tan inverse on -pi over 2 to pi over 2. So you have to remember that, and you need to adjust your answer, and the way you adjust your answer is adding B. So if I get an answer on my calculator, and I'm down here, this is my theta prime answer, because the calculator is going to give me some negative angle, then I'm going to add pi to my answer in order to put me back to where I need to be, because this is the theta that I want. And to get back to this terminal side, I need to add pi to that calculator answer to be back into the right quadrant. Let's find the absolute value. Let's see, I didn't label these. Let's go back a minute. This is magnitude. This first expression is the magnitude. It was also the hypotenuse of that right triangle, and it's called the absolute value or the modulus of the complex number. So when we see this notation, find the absolute value of z and the theta. And our angle is -5. So we're coming over on the x-axis -5, and we're going up 12 on the imaginary axis. This is our terminal ray here. So we're in quadrant 2. Dropping that perpendicular back to the x-axis, the length of this side is 12. The length of this side is 5, but we're going in the negative direction. The absolute value is the hypotenuse. Our x value, or real number part, is -5. Our imaginary part is 12. 25 plus 12 is the square root of 169. And the square root of 169 is 13. So our hypotenuse is 13. Now, using our calculator, we want to find the angle where the tangent is y, or b over a. And our answer becomes -1.176. So where is that? Think about that restriction. So our calculator gave us this answer, -1.176. And we want to add pi back to that to get back to our angle in quadrant 2. So the angle we have in quadrant 2 is going to be 3.14 minus 1.176. So we're going to be at 1.966. That's where we are in quadrant 2. Let's try number 11. Find the absolute value and the angle, then graph -7i. Okay, I think we can figure this one out just by inspection. Because think about, on the real number part, we're at 0. So this is 0 plus 0 minus 7i. 0 minus 7i. So we are nowhere on the x-axis, and we are down here on the y-axis. That angle, if you think about that angle, that's 3 pi over 2. So the magnitude, or the absolute value, is 7, and the angle is 3 pi over 2, or -pi over 2, if you want to answer that way. Polar form of a complex number. Again, this is something that you can use in a BC calculus class. The cosine of theta is the a value divided by the r value. So a is r cosine theta, just like we saw before. X is r cosine theta. Y is r sine theta. So b is r sine theta, because we are using a and b. A for the real number part. A for the real number part. Whoop. And b for the imaginary part. Within that right triangle, where our terminal side is up here. This is r, this is theta, and we have an a comma b. This is our vector. That gives us polar form. We use polar form is z. Z is r cosine theta, because that's the a value here. And b is r sine theta, but we have an I in there, so I'm going to put the I up in the front. I times r sine theta. That's called polar form of a complex number. And a complex number has the polar form or trigonometric form. If you would, this is what we just wrote. They factored out the r, and the magnitude is the hypotenuse. The angle is the b over a, and the number r is called the modulus of z, and the theta is called the argument of z. Write the complex number z equals radical 3 plus I in polar form. So that should be fairly easy. We know A is the real number part. That real number part is radical 3. So our A value is radical 3. Our B value is the imaginary part. That's 1I. Our R value is the square root of 3 squared. The square root of 3 squared plus 1 squared. So that's 3 plus 1 is 4. The square root of 4 is 2. That's our radius. And then our complex number is R. It can be written as Z equals R times cosine theta plus I sine theta. And we want to draw our picture over here. This is our terminal ray out here. R is 2. Theta is pi over 6. The perpendicular length is 1. That's the imaginary height. The real number distance is radical 3. And then we can write our equation. So we know that this is a pi over 6 angle based on the sides of the triangle. So our z, or complex number, is 2 cosine pi over 6 plus I sine pi over 6. Writing trigonometric form or polar form of a complex number. Let's try one more of those. We want to write the complex number square root of 6 minus I radical 2. Square root of 6 is the direction on the real number axis. Negative square root of 2 is the direction on the imaginary axis. That's our terminal side right there. This is our theta. Our job is to find the absolute value or the magnitude. So A is radical 6. B is negative radical 2. If we find R using our formula, square root of 6 squared plus the square root of negative square root of 2 squared, that's 6 plus 2, that's 8. The square root of 8 can be simplified to be 2 square roots of 2. So we have this as 2 radical 2. And then I know that my angle is also going to be a pi over 6. Think about the tangent of theta has to be opposite over adjacent. And it's under the radical, which is negative 1 over square root of 3. That's negative pi over 6. So our theta is negative pi over 6. And we know the radius, 2 radical 2. Theta, if we go in a positive direction, that would be 11 pi over 6. I like to write these with positive angle measurements, not the negative angle measurement. So our polar form of this complex number is 2 square roots of 2 times the cosine of 11 pi over 6 plus I times the sine of 11 pi over 6. Polar form of a complex number, also called trigonometric form. Let's change from polar form to rectangular form. So we're going to look at that. Whoop. As soon as I can get my screen to move. Okay, changing this polar form, we're given polar form, we're going to convert it to rectangular form. What do we know? We know cosine of 3 pi over 4 is negative square root of 2 over 2. We know sine of 3 pi over 4 is positive square root of 2 over 2. So we can replace those expressions. 5 times the cosine of 3 pi over 4 plus I times the sine of 3 pi over 4. And then we can distribute the 5 to both terms. So the rectangular form is negative 5 times the square root of 2 divided by 2. That's our real number part. And then our imaginary part is positive 5 square root of 2 over 2 times the imaginary part. We converted polar form up here to rectangular form down here. For number 15, we know cosine of 4 pi over 3 is negative a half, and we know sine of 4 pi over 3 is negative square root of 3 over 2. So our rectangular form will be 3 times negative 1/2 plus negative square root of 3 over 2I. That gives us negative 3 over 2 minus radical 3 over 2I. From polar form to rectangular form of a complex number. Then moving on, we also have product and quotient of complex numbers. Again, this is not something tested on the AP pre-calc exam, but we can follow this rule. For the product, we're going to multiply the radii together. So Z1 times Z2 would be multiply the R times the R. That's 2 and 3. And then we're going to add the angles for cosine. Pi over 3 plus pi over 4 is going to add up to 7 pi over 12. And then I times the sine of pi over 3 plus pi over 4. So we would get a common denominator. That product, Z1 times Z2, is 6 cosine 7 pi over 12 plus I times sine 7 pi over 12. I'm calling this polar form. This is polar form. If you got a calculator out, we could turn that into rectangular form. So if you needed rectangular form in an AP Calc class, you could say that product, Z1 times Z2, is negative 1.553 plus 5.800I. This is the answer that we were interested in from the directions here. All right, so example 17, we're going to divide this time. We're dividing the R1 and the R2, that's 2 over 6. So Z1 divided by Z2 is equal to 2 over 6. And we're going to subtract the angle measurements. Cosine 9 pi over 16 minus 3 pi over 8 plus I sine 9 pi over 16 minus 3 pi over 8. 2 over 6 is 1/3. So Z1 divided by Z2 is 1/3 cosine 3 pi over 16 plus I sine 3 pi over 16. And they wanted polar form, and there we have polar form. This is polar form. And then our last example is using de Moivre's theorem. Again, not tested on the AP pre-calc exam. If Z is R cosine theta plus I sine theta, if that's a complex number, and we want to raise z to a power, we're going to raise the r to the power and then multiply the value of our exponent times the angle measurement. So we need to know two things. We need to know the r is 2, and we need to know the n is 4. And following our pattern here, z is 2 to the 4th cosine 4 times pi divided by 12, so 4 pi over 12, which will simplify to pi over 3. And then I sine 4 pi over 12. 2 to the 4th is 16. And then we want cosine of pi over 3 plus I sine of pi over 3. And then simplifying that, cosine of pi over 3 is going to be a half. So z is 16 times 1/2, and sine of pi over 3 is radical 3 over 2. Let's distribute the 16. Half of 16 is 8, and 16 times I radical 3 divided by 2 is 8I radical 3. This is what is called standard form. Standard form for z equals a plus bi. And that, my friends, is the end of Lesson 13 in AP Pre-Calc.